minus 5 megapascal. Okay, so which is true. Okay, so this intersect here slightly off a bit. I think it's my lines. Okay, so we calculate, we discover where is the center of our circle now. Okay, so this is the center of the circle. Okay, so we just discovered that this is our stress average. Okay. Then the next thing that we can immediately calculate is the radius of the circle. So the protocol is always the same, okay? You calculate the center of the circle and you calculate the radius of the circle, which is your tau max. Okay. Now tau max has formula, but I don't want you all to apply the formula, okay? I want you all to just to do this, okay? Just observe the circle. So the distance from here to here, right, is how many? Okay, so 5, 10, 15, 20, 25, 30, 35. 35, right? So 35, so square root of 35 squared plus by the height, okay? So plus this distance over here, which is 15. Okay, so 15 squared. So 35 squared plus by 15 squared. Okay. Square root of the whole thing is 38.079 megapascal. Okay. So what we just did down there, okay, is from the center of the circle, right? We determine this distance. Okay, we just determine this distance over here. Okay, so this is the radius of circle. I better write at an angle. I know it looks confusing. Okay, so now we know the radius of the circle. We can find the principal stress. This is your stress 1 on stress 2. So it's equal to minus 5 plus or minus 38.079 megapascal. Okay. So minus 5 plus 38.079. So this is 33 positive 33.079 or minus 43.079 megapascal. Okay. So now we can digitally draw our Mohr circle. So 33 is somewhere around here. And then 43 is somewhere around here. Okay, so now I can sketch Mohr circle, or you can use using your mathematical set, you can draw your Mohr circle also. So the height is 38. This is just a ballpark. 38. Okay. So this is your Mohr circle now. Okay. So let's recap what have we done. Okay. We have determined our principal stress. We have determined not principal plane. We have determined our principal stress. We have determined our maximum in-plane shear stress. Okay. Next, we're going to determine our principal plane. Okay. So to determine our principal plane, So the principal plane you can determine from point X or point Y does not really matter. Okay. So this over here, if we determine from point X, this is our 2 theta P. Theta P means our principal plane. If you determine from Y, the rotation direction is also the same, 2 theta P. Okay. So tangent 2 theta P is equal to 15 divided by 35. Okay. So 2 theta P is equal to 15 divided by 35 inverse tangent 23.2 degrees. And it's going in a clockwise direction. Then theta P is equal to 11.6 degrees. Okay. So we are done dealing with the principal plane orientation now. Okay. So the next part we're going to do is we're now going to sketch, okay, the element orientation at its principal plane. Okay. So now what we have just done before is we gone from element to Mohr circle. Okay. So we found some of our values. So the next part I'm going to do is how are we going to get from Mohr circle to element. Okay. So this is the complete lecture of doing Mohr circle. You have to go from element to Mohr circle to element. Okay. Now this is a simple one. Later on we'll do a more difficult one. So from here, right? From here, now we know. Okay, we're going to do the original axis. Okay, so this is the original axis. Okay, this is the original axis. The next thing we have to do now is we have to rotate the axis to its principal plane, and it's in the wait, I think I got it wrong. It's anti-clockwise. It's not clockwise. Okay, my apologies. Anti-clockwise. Okay. So we are going to rotate 11.6 anti-clockwise direction. So I'm going to draw the principal plane orientation now. Okay, so this is about 11.6. Okay. I'm going to copy, and I'm going to rotate 90 degrees. Okay. So that's a principal plane orientation. Okay. So this to here rotate anti-clockwise 11.6 degree. Okay. Then I'm going to sketch the element now. Okay. Then we're going to draw a vertical line. This vertical line is your point X on Mohr circle. Okay. This horizontal line is going to be a point Y. Okay. So we know that the rotation this way, right? This way of rotation, that is your 11.6. Now, this is why I want you to draw the circle, okay, not just rely on transformation equation, okay? Because now, then we can know, right, when we rotate, what is the stress field. If you calculate you are not sure. But when you draw Mohr circle, you'll be sure. Let me elaborate. Okay. So at point X, right? Okay. At point X, we rotate anti-clockwise by 23.2 degrees, and we reach this point over here. And that point over there is 33.079 in tension. So now we know that this is going in tension 33.079 megapascal. Can you see that now? Right? You can now you know why that's 33.07, right? You can visually relate it, okay? Then from Y, you rotate anti-clockwise by 23.2 degrees. You have this point over here, and this point is your what? Your minus 43.079. Okay, so now you know over here is your minus 43.079. Okay, so this is what I mean by now you can move from Mohr circle to element. Okay, now if I just show you this, right, just show you the calculation, you cannot sketch the element because we are not sure what is stress 1 and stress 2 in what direction. We don't know. Okay, so this is the purpose, okay, why I want to teach you using drawing the circle. This is one of the reasons that we can go from what? Element to Mohr circle, then from Mohr circle back to the what? Element. Why you have to bring it back to element? Because element is the real life. Physically, what does this mean? Okay, just very good timing. Go for a 15 minutes break. Okay, go for a good 15 minutes break, and when we come back, we will do more complex problem. Okay, not super complex. Sorry, not super complex, but just more complex. Okay. Okay, go for your break.